Hey Brad, when something blows up, why do you think it makes a mushroom cloud?
I don't know. Hey guys.
Hey.
Hey. It's actually formed due to density differences, gravity, and Rayleigh-Taylor instability.
Due to the diffusive properties of mass transfer and the turbulent nature of air, they're very easily observable.
What?
This is what we get for being expositional devices. How about a montage?
Ooh, on it.
When an explosion occurs, hot dust and other particles are thrown into the air. This creates a mixture that is denser than air, but that is still being propelled upwards. There are opposing forces at work. Gravity wants to drag the mixture down, but the explosion is still forcing it upwards. This is called Rayleigh-Taylor instability.
Eventually, the dust mixture loses momentum as gravity pulls it down. Because the surrounding air is turbulent, it doesn't flow in an orderly fashion, and little whirlpool-like areas called eddies form. These eddies pull the ascending dust outwards and downwards, circulating the mixture and creating the distinctive cap of the mushroom.
So that's cool and all, but why is it important?
Because it shows the importance of convective mass transfer. Turbulence and eddies don't just happen when you blow things up.
Aww.
It also happens in pipes, tanks, anywhere you have a fluid. As chemical engineers, you'll solve problems like this to work on anything from pipes to jet engines.
Without these concepts, planes wouldn't fly, hot air balloons wouldn't float, and many of the products that we use today wouldn't even be available.
Whatever. Can we make one?
Sure, why not?
Yes. So what we have here is an oil and water system which we're going to use to create our own miniature mushroom cloud. This system makes it very easy to see how density has an impact on mass transfer as well as several other parameters. As we discussed before, things always flow from more dense to less dense. In this case here, we're actually making an upside-down mushroom cloud. The oil wants to float acting the same way as gravity, but in the opposite direction.
What we're going to do is change how fast the oil flows and see how that impacts the size of our mushroom cloud. This increases the oil's momentum, so it takes longer for buoyancy to counteract it.
As you can see, increasing the velocity of the fluid increases the height of our mushroom cloud, which is mathematically consistent with our prediction based on mass transfer. Now imagine the size of a mushroom cloud created by an atomic bomb, and think about how fast the debris in there is moving.
Wow, that's fast. How fast would it be, though?
Fast enough to look cool in slow motion.
Cool guys don't look at explosions. They blow things up and then walk away. Who's got time to watch an explosion? There's cool guy errands that they have to walk to. Keep walking, keep shining. Don't look back, keep on walking. Keep strutting, slow motion. The more you ignore it,